All right, welcome back to ACIB. So today we're going to be talking about statistics, and specifically sampling and data presentation. So first I'll talk about what statistic really is. So statistics. Well, statistics, sorry. Well, statistics basically is a branch of mathematics that collects data, analyzes data, and then uses that data to make a prediction, inference, or decision on a whole population. In some cases, it might not be for a whole population, but most oftentimes it is. And because we want to know something about a whole population, sometimes that whole population is too large for us to ask every single one in that population for details. For example, if we wanted to know what the favorite ice cream flavor of everyone in your school was, it might not be very practical to be asking your entire school for that data. Instead, maybe we select some random people or we select a class. So what we do is we take a sample, and this sample is part of the whole population. And then, based on the data we collect here from the sample, we can make inferences back at the whole population. And that's basically what statistics is. Now, let's talk about different ways to sample. These are called sampling methods, and in IB, we learned 5 of them. So, how do you get your data? Well, the first type of way is called a simple random sample, or simple random sampling. In short, we can also say SRS. Now, what this sampling is basically you're just choosing random people from the whole population. So maybe you want to know, out of the 1,000 people at your school, what flavor ice cream is their favorite. Well, maybe you're going to choose random 100 people and ask them. And then you'll make an inference on the 1,000 people. So this is called simple random sampling because it's very simple and it's pretty random. The next type of sampling is called systematic sampling. So in this type of sampling, we're going to pick a random starting point. So let's still say we have 1,000 people that really like, and you want to know what their favorite ice cream flavor is. We're going to choose a random number. So let's say we choose 80. Then we're going to sample every 10th person. So we're going to sample the 80th person, then the 90th, then the 100th, then the 110th, so on and so forth. So this is called systematic sampling. So here, grouping of the population becomes very important because let's say that in your school, like let's say 250 were grade 9s, 250 were grade 10s, so on and so forth. Then, and if they were actually in this order from 1 to 250, 250 to 500, then this would make sense because you're getting an average of a quarter from each of the grades. However, if, let's say, every 10th student, as we did here, every 10th of them, they were all in grade 9, then that wouldn't make much sense because essentially you're going to have a heavy bias towards the actual ice cream flavors of grade 9. The next type of sampling is called convenience sampling. And like the name suggests, you're basically sampling from whatever is convenient to you. For example, if you were, once again, sampling your school for their favorite ice cream flavors, you might be just standing in the cafeteria. and asking the first 100 people that you see. So once again, this kind of sampling might be convenient, and oftentimes it's what people will do to get their data. However, it still leaves room for bias, because you never know if maybe that day there was only strawberry ice cream in the cafeteria, and therefore all the people in the cafeteria were ones who liked strawberry ice cream. So once again, there is big bias in this type of sampling. The next type of sampling is stratified sampling. And this type of sampling basically means you're going to separate the population into subgroups. So for example, I might separate the school into two groups, males and females. Then I would pick samples from each group. So I would maybe pick 50 from this group and 50 from this group. So this kind of addresses some of the issues when dealing with simple random sampling. Because in this type of sampling, we're guaranteeing that both subgroups have an equal voice and equal power to the final sample and data that we get. And finally, the last type of sampling is quota sampling. And this type of sampling is very similar to stratified sampling. But instead, this time, we're going to pick proportional samples according to the proportional subgroups in the population. So, for example, maybe my school has 60% females and 40% males. Well, in that case, it wouldn't really make sense for me to still choose 50 females and 50 males for my comparison. And instead, maybe I would just choose 60 females and 40 males to sample my data. Now, like the good statisticians that we are, we want to minimize our bias. So bias is big no-no. So there's certain ways that we can, or certain measures that we can take when we're sampling for data to minimize our bias. Now, in the end, there will always be bias, and it's something that we can't really completely get rid of. So some measures might include collecting data in a different way, setting up groups, choosing a different sampling method. So now let's talk about data. So first of all, there's a few different types of data, or only two in fact, but basically data can either be discrete or continuous. And what this basically means, and to be honest, I found this very confusing at the start when I just learned this, but the difference is continuous can take any value. So what this means is that if you were, let's say, measuring the temperature, right? The temperature can realistically be any value. It doesn't have to be an integer value. Or on the other hand, discrete must be certain, only take certain values. So this would be how many students are at my school. There definitely cannot be 503/4 students. Like that just doesn't make sense. So, but on the other hand, digits, even though maybe your thermometer can only handle digits out to the 100th, realistically that temperature can be any value, even if your thermometer can't measure the exact value properly. But still, that value can take on any value, so therefore that data is considered continuous. So anyways guys, that's it for this video. Thanks for watching, and I'll see you guys in the next one.